What's that? More shales up here.
Yeah.
All right. Were you able to pick up any patterns at all? What's that? I mean, was it just an increase in shale? Did it just uniformly increase in shale?
Well, I thought first the sandstones got thicker and then they disappeared.
Yeah. Okay. So what does that mean? Anybody got a back of a sheet of paper I can draw on?
Draw on mine.
Draw on mine, right. What we are seeing here is something that we're going to deal with a lot stratigraphically before we're done. And I haven't introduced it to you, at least in any formal sense, although probably by not next week, the week after, I will be into this stuff. But as we were coming up, we were having a bunch of interbedded sandstones and shales, all right? And then up here, it seemed to be just mostly shale. But occasionally, like right there, you got a relatively thick sandstone. Now, stratigraphically, those things are really important. And there's a whole body of theory behind how these patterns are produced. And those patterns help us sort out sea level changes, and those patterns help us do environmental interpretations, transgressions, regressions. So you can see we're going to do a lot with them. But what we're dealing with here are things called para-sequences. And para-sequences are usually interbedded bodies of sandstones and shales that go anywhere from a couple of meters to 20 meters thick. So they do vary, but they're interbedded units. And within those, they can either be coarsening upward or they can be fining upward. Now, if you're dealing with one which is coarsening upward, that means you're going to be dealing with a lot of shale, and then you're going to start to get some relatively thin sandstones, and then the sandstones are going to begin to thicken up section, and they'll eventually begin to amalgamate. Have you heard the term amalgamation yet? Okay, because we're going to do it again today, this afternoon. When we talk about amalgamated sands, we're talking about what looks like a big, thick body of sand. But that body of sand represents more than one depositional event. So it's like I've got a sandbar, a storm comes and moves it, and then I go into 5 years of nothing, and then the next storm comes and moves it again. And so when we have a sand body that has multiple events in it, it's said to be amalgamated. And this afternoon when we get to Brock's Gap, we'll deal with it where we can actually see some evidence for it. So this would be a coarsening upward parasequence. Alternatively, you can have fining upward parasequences where you begin with nice thick sandstones, and then these things become thinner and thinner and thinner until finally they're going to cap out in a shale zone, and then you'll go into another thick sandstone. Whether the parasequence is coarsening upward or fining upward can help you determine what environment you are in. If they are coarsening upward, that's usually an indication of a shelf environment. If they are fining upward, well, that shows up in submarine fans, and it shows up in tidal systems. Now, Like I said, this is not the best outcrop to do this because all the evidence isn't exposed. But start down at the bottom again, and now I want you to look specifically. See if you can find the coarsening and fining upward patterns. In particular, see if you can find the boundaries between parasequences. See if you can find where there's a shift in the trend.